Good with multiplying polynomials, we go on to the second half of P3. Our mission for today is to multiply polynomials. And in order to multiply polynomials, we keep it kind of simple to start off with. In this next example, under key point 2, what we're going to practice with is the distributive property and a little bit of our properties of exponents. So if you take a look at example 3 here, I'm asking you to find the product of 2x times the quantity of x squared minus 5x plus 2. So I have a monomial times a trinomial. It's a monomial, remember your definition from last week. A monomial, you look at the exponents. The exponent has to be a non-negative integer. So as I look here, I have 2x to the first power. And 1 is a non-negative integer, so I can just use my distributive property to get that 2x into the parentheses. Now, I'm going to show you what's going on in my head when I distribute. I know, based on your pretest, that most of you are pretty good with the distributive property and FOIL. But just to be very clear and get us all on the same page, I'm going to show you what goes on inside my head when I do FOIL and when I do the distributive property just one time. Okay? So if you take a look right here, I have 2x, and I'm asked to distribute it to x squared minus 5x plus 2. That means I need to distribute the 2x to the x squared, the 2x to the 5x, and the 2x to the 2. And when I distribute, I multiply. So quite literally, what I'm going to have to do is take 2x times x squared, bring down my minus sign, and then I have to take 2x times 5x, and then I have to take 2x times 2. You don't have to show this step on your homework, but since you can't see inside my brain, I wanted to show you what I was doing. What goes on the smartboard must go in your notes. Okay, so now I'm going to utilize two things that I know. I'm going to utilize from P1 my associative property of multiplication to sort of rearrange things a little bit in my head. And from section P2, I'm going to use my laws of exponents. For instance, if I have to multiply 2x to the first power times x squared, I know that I could rearrange this multiplication just a little bit in my head. If I wanted to, I could actually just multiply x to the first times x squared. X to the first times x squared. I have like bases multiplied together. So I have a question for you, my very smart period 5 college algebra class. What do I do with these exponents? Michael? Yeah, I heard it around the room. Very good. You add them together. So that's just another reason. You use properties of exponents all the time. You probably don't even know you're doing it. So, yes, we have 2x to the third power. So I use my associative property and my power of a product property. Next, in the second term, I have 2x times 5x. Again, I'm going to regroup this a little bit to make it nicer to use. I would take 2 times 5 and make that 10, and then x to the first times x to the first, that's x squared. And then I have to take 2x times 2. Of course, I just bring down my plus sign prior to doing that. 2x times 2, 2 times 2 is 4. X. There it is. Notice, because my problem was originally in standard form, my answer comes out in standard form, so that's kind of nice. Questions about example 2, a monomial, or example 3, I'm sorry, a monomial times a polynomial. That was our distributive property and properties of exponents. Okay, now, making it a little trickier, I'm going to take a binomial times a trinomial. This is just a more organized version, a longer version of the distributive property once again. Part of it's going to look really familiar to you because we already took 2x times x squared and 2x times negative 5x and 2x times 2. For the second part of the problem, I'm then going to have to distribute the 5 in as well. So here's how that's going to look. When I distributed the 2x into the same trinomial in the previous problem, I did get 2x to the third minus 10x squared plus 4x. You might recall that from that previous example right there. Now I have to distribute the 5 in as well. Notice in this particular problem, I'm going to distribute a positive 5 in. But you do need to watch your sign there. If that were a minus sign in between, you would want to distribute the opposite in. In other words, you would want to distribute your negative 5 in. Regardless, you're always going to combine the result of these two polynomials. So I'm always going to add them together. Here I'm distributing a positive 5 into that second trinomial. Second trinomial. So we have 5 times x squared. That's going to be 5x squared. And notice I line up my like terms, so I have x squareds under x squareds. And then I have 5 times negative 5x. That's negative 25x. And then I have 5 times 2. That's 10. Don't write it down unless you understand it. I see you guys writing. Does anybody have any questions about this so far? Okay, good. Nice job. Way to hang with me. All right, so now it's just like a problem on last night's homework. See why it's important to add and subtract polynomials before we multiply them? I'm adding two polynomials together. So now I can find the sum. 2x cubed plus nothing, 2x cubed. Negative 10x squared and 5x squared, negative 5x squared. Positive 4x and negative 25x, negative 21x plus 10. And notice, because my original problem was in standard form, my answer comes out in standard form. Questions about that? All right. We have another set of polynomials to multiply. We have binomials times binomials. In other words, 2 terms times 2 more terms. The product of things that have 2 terms in them. So whenever you're asked to multiply binomials specifically, we use a process called FOIL. And judging from the pretest, most of you are very, very good at this. But I did want to touch over it just briefly for a couple of you that, especially with part D there, need a little refresher on something. So for key point 3 here, it says when we multiply 2 binomials, we FOIL. What does that stand for? Does anybody know? Ooh. Yes, is that what you were going to say? Yes, yes, good job. First, outers, inners, last. Firsts. Notice there's a plus sign in between because we add the F plus the O plus the I plus the L. So first, outers, inners, last. So for instance, in part A, our firsts would be the x's. So we take x times x, that's x squared. Outers, the outermost parts of the problem, we have an x and a positive 7. You multiply those together, you get 7x. We always add. My inners would be negative 7 times positive x. That's negative 7x. And my last, negative 7 times positive 7 is negative 49. On your pretests, a couple of you stopped there. Not quite done. You have to go just a little bit further. What do we do to simplify this expression? Combine your like terms. Yeah, very good. So in other words, positive 7x and negative 7x, those undo each other. The best answer for this problem is x squared minus 49. What's up? You could factor it, yes. But this problem here just says find the following product. So here's the thing that's going to happen, Lyra. If you were asked to factor x squared minus 49, you know what you're going to get back out? The original problem. So we don't actually go that far because I asked you to find the product. Make sense? Okay. For part B, but I like that you're thinking ahead a little bit. We are going to factor here a couple weeks, I think. So we have x plus 3 and x plus 5. We're going to FOIL those, doing our first outers, inners, last. X times x is x squared. Outers is 5x. Inners is 3x. Your last is 15. And then, again, on the pretest, I saw a couple people leaving it like that, but you got to combine your OI. So your outers and your inners. Those usually, not always, but usually end up being like terms. So this is going to be x squared plus 8x plus 15. The final answer there. Part C, same deal, except this time around, I have a coefficient in front of my x. So what I have going on there, 2x times x gives me 2x squared. So notice when I got a number in front of my x squared, there was also a number in front of my x right there. That's going to be important when we have to go backwards, aka factor, you know. And then my outers is going to be 4x, my inners is going to be 5x, and my last will be 10. So final answer to this guy here is 2x squared plus 9x plus 10. Okay, and one of the common mistake on the pretest for part D, see how we have the quantity of x plus 2 squared? It's actually one of the most common mistakes in all of algebra. You're allowed to distribute that exponent into that set of parentheses. No, we are never allowed, and what's tricky is that this book puts this skill in with properties of exponents, where I was just trying to drill into you to distribute your exponent in. But remember what came out of my mouth. You're allowed to distribute the exponent as long as there's no plus or minus in the parentheses. So this is the case I'm talking about. Do you see how there's a plus in those parentheses right there? You cannot distribute that exponent in. X plus 2, quantity squared, literally means you're taking x plus 2 times x plus 2. That is a FOIL problem in disguise. You're not allowed to distribute that exponent in because you won't get your outer and inner term. So we get x times x, that's x squared plus 4x plus 4. If you accidentally distribute the exponent in, you lose this whole term of 4x in there. Your answer is off by 4 times the value of x in this case. Essentially incorrect. So watch out for that. All right, I'm going to go ahead and give you guys a chance to practice this real quick. There's 2 on the bottom, parts A and B for independent practice 2, but then it trickles over onto the next page where you have C and D to take care of. So I'd like you to just review that for a second. I'm going to walk around and start checking off the homework. You a couple of answers to your independent practice. So we're going to do that now. So I think, where was I? Next slide. So as far as parts C and D are concerned, at least, for your independent practice here, we have x squared plus 18x plus 81. And then for part D, you have x squared minus 9. On the previous slide there towards the bottom, you had part A, x squared plus 3x minus 28. And part B, you had 6x squared plus 11x plus 4. Okay, did anybody miss any of those FOIL problems? A and B, C and D. They look pretty good as I was also looking at the homework. We're good? Nobody wrote x squared plus 81 for part C? Oh, that would be the wrong one. All right, in example 6, I just wanted to talk with you briefly about, well, what do you do if it says cubed? How do you work that? What we're going to actually end up doing is foiling and distributing. So if you take a look at example 6 here, we have x plus 5 quantity cubed. Now we were just talking about how you are not allowed to distribute that exponent in when there's a plus or a minus in the parentheses. So x plus 5 quantity cubed literally means we have to take x plus 5 times x plus 5 times x plus 5. And then we FOIL these back two. Reason being, that's personal preference. I like to FOIL the back two because then I have a binomial times a trinomial like we already did together as a class. So I'm going to FOIL the back two binomials, and here's how that's going to look. First is x squared. Outers and inners combine to make 10x. And then our last, 5 times 5 is 25. So that's me FOILing the back two. And then what I'm going to do is I'm going to use my distributive property along with my laws of exponents to simplify the product of this binomial times this trinomial. In other words, I'm going to distribute the x in, and then I'm going to take a moment to distribute the 5 in. So here's how that's going to look. If I distribute the x in, x times x squared is x cubed. X times 10x is 10x squared. X times 25 is 25x. Then then I need to distribute this 5 in, and I'm going to pair up my like terms. So when I distribute my 5 in, I have 5 times x squared, that's 5x squared. You see where I wrote that? Underneath my 10x squared, because those are like terms. And then 5 times 10x is 50x. And then 5 times 25 is 125. Haley, you okay, hon? Yeah? Okay. So add them up. We have x to the third plus 15x squared plus 75x plus 125. That's our answer. Yes. Yes. Is my pass back there? No. You gotta give it a second pat. I'm sorry. Okay. You ready to try, or you think you need to see another one? You think you're good? Okay, so to finish up, I'm going to go ahead and check out. Oh, yeah, that was a funny little graphic I found on the internet. Moral of today's story, the big mistake that we see, I guess, apparently it causes the death of puppies. If you distribute an exponent into parentheses. What's that? Are you really? Yeah. Really, no puppies were harmed in the making of this slideshow. That was my disclaimer for PETA members. Okay, so yes, don't distribute an exponent in when there's a plus or minus. So right now, you can go ahead and take care of example 7 for a little bit of practice, and then there's a couple leftover independent practice problems at the very end. I'll go ahead and show you these answers before you leave to make sure you have like a good handle on the particular skills I taught you today. In other words, how do you multiply polynomials? And then I'm going to finish. All right, so last couple of examples and independent practice problems. I just wanted to show those to you real quick. Example 7. Final answer, I'll highlight it for you. It's right there. Hopefully, if you did the problems correctly, you got 8x to the third plus 12x squared plus 6x plus 1. Questions about that? Okay. For our independent practice problems, the 2 at the very end, please do not distribute that exponent into parentheses. You have to write that out literally for part A and B 3 times. And then for part A, we get 8x to the third minus 12x squared plus 6x minus 1. And then for part B, you folks did a pretty nice job. I saw most of you got 27x to the third plus 54x squared plus 36 plus 8. All right. You have about 2 or 3 minutes left. Preview of coming attractions. Ultimately, by the end of, I was shooting for today, but tomorrow, Chapter P should be completely filled in. All the independent practices, all of the definitions, all of that should be done. If you need a minute tomorrow in class to do that, you can. And then ultimately, we're reviewing for our Chapter P quiz, which is on Wednesday. Bookwork tonight.